Hey everybody, today I have something a little different from my normal channel. I have what's called a sCMOS camera, so that's scientific CMOS. This camera is made by Photometrics, who is now bought up by the defense contractor Teardown, so the newer cameras have Teardown plastered on the side of them, but they're the same camera. What is an sCMOS camera? It is a scientific CMOS. And really where these are typically used is low light imaging, so taking pictures of space or biosciences for like bioluminescence under a microscope. And the reason for that is they are incredibly good at low light imaging. And how they get good at that is one, large camera pixels, so this is only a 1 megapixel camera. But then two, that image sensor, the silicon and the readout electronics are cooled to, in this case, minus 20 degrees C through something like a thermal electric cooler. And then that extra heat is blown away through either a fan or this system does support liquid cooling. So this video I'm making because I used some of these and one of them started intermittently failing. It randomly loses connection to the computer. So I'm going to do a rough teardown, just high level, not actually tear down the camera all the way, enough that I can still hopefully send it out for warranty. But I just want to take a look inside and see what's going on and show it to you guys, since I don't see anything on YouTube of people really examining these much at all, which, good reason, they're pretty specialized. There's probably not a lot of them made. But I thought it's an interesting topic that I'll cover that's a little different from the typical channel stuff. So let's take a look at the bench and let's find out what we see. Alright, here we have the camera on the bench now. It's a nice solid feeling aluminum extrusion with mounting holes on all four faces. They're US bolts. There is a fan for coolant, so there's holes. It sucks air both way, straight through the camera. You can kind of see the heat sink inside of there. When we open it up, we'll see more during a quick teardown. On the faceplate, there's no mounting. There is just a standard C-mount thread, and then you can see the silicon sensor in there, most likely under a piece of glass, so not too exciting. Now the most interesting thing is probably the rear of this camera. We have a few different things going on here. So first of all, these cameras allow two different interfaces. One is a USB 3 interface. They also allow a 4x wide PCI Express interface. You can technically get a faster frame rate here, but you cannot be using the full image sensor size if you really want that high frame rate. You have to either do binning or read out a sub ROI. Historically, I only stick with the USB. The PCI Express interface is real touchy. There's kind of a startup sequence. We find different BIOS on different computers don't always handle it very well, so USB seems to be the best. You'll also notice it has quick connect water cooling here. So if you don't want to run the fan for vibrational or noise purposes, you can liquid cool this system with something similar to what you'd use inside of a PC cooler. Power switch. It uses quite a lot of power, 120 watts at 12 volts, so you have a DIN connector there. And then it has a trigger connector here, and that's more than just triggering. It also has output signals and input signals. It's nice. There's some signal lines as far as when you're exposing, when the camera's ready to expose, etc. It's like TTL logic levels. Pretty easy to work with. So that's the exterior. Let's take a look at the interior. So taking these cameras apart is actually quite easy. Starting from the rear, since this is all extruded aluminum, it's just held together with some basic screws. The inside is actually quite interesting. To start out with, you actually need a Phillips screwdriver to remove this water block here. Then it's metric hex to take off these 4 back screws. I've already removed these for the sake of time, but just your typical cap screws. At which point these plastic corner pieces come off. Then there are 2 more holes for this water block that you need to unscrew, at which point this cap just freely lifts off. Now, this is most likely very static sensitive inside of here, so you want to be working on a static pad, static wrist straps, etc. Cameras are not cheap. So once that happens, you can look inside the camera, but you can't really access much from this point forward. So then what you want to do is flip the camera over, and you'd want to basically do the same thing on the rear. There would be 4 of these caps. Same thing, you just unscrew these 4 caps, and that loosens up this center aluminum extrusion piece. This whole piece here is now loose. What I am not going to do, and I have not ventured into doing it, is you probably do not want to take off these screws here that are holding this C-mount image sensor in place. I would assume that could grossly affect the camera performance, alignment, etc. But by taking these outside sets off, I've found it's actually pretty easy to hold it like a popsicle from a lens, and then you can just freely lift off that aluminum external housing, exposing the inside of the camera. All right, I'm gonna flip it on its side, and we're gonna walk through all the primary pieces. All right, so starting from this side, you can see these water coolant lines, which are actually discolored in this one due to incompatible coolant. They run into this block over here, which I'm assuming has the thermal electric cooler in it that's cooling the image sensor here. And it also makes sense, you have this big heat sink attached to it where the fan is blowing through. First thing out of the gate, we've had some of these tubes detach internally and flood these cameras with cooling fluid. There's no barbs on them, they're just a press fit, so that's kind of a weak part of the design. One interesting thing while we're here, it's hard to see at this angle, but this is where the camera design got interesting. So there's a circuit board on each side, and they're actually using another edge connector board to interface between them instead of a cable, etc. So this is where like the mechanical designers and electrical designers were really in tight communication. Rolling over to the back here, trying to get this at a point it's not going to glare. This is, I'm going to say, the high-speed signal electronics processing side of this camera. So these blocks here are 1 gigabyte DDR3 RAM modules. I can kind of see an array here if you look closely. This is probably a large FPGA. It's under a heatsink on the other side, so you can't really determine what is quite there. But in general, this is high density, probably very static sensitive on this board. This is really what's doing all the compute buffering, etc. Rolling to the next side. Now this is really interesting. They just have a simple cooling fan, but what's really nice is this whole fan is actually mounted on a spring system, so it's floating, so it doesn't vibrate the chassis of the camera. And even that system is now again mounted on rubber grommets. I've taken one of them off just to disassemble this. But they put a lot of effort into reducing fan vibration, which leads me to believe that fan vibration on these types of cameras must cause issues. Finally, this final side here, just judging by some of the components on this side and the other side, is most likely primarily power conversion. Maybe some of the trigger signals are coming in here, but primarily I believe this whole board up here is power conversion. Looking in from the top, it's hard to see in there, but really you have a lot of power-like components, power filtering, etc. on that power board, whereas on the logic board, you really can't see much. It's all covered under these heat sinks in here. For cooling purposes. But then you do have this top board, which I'm assuming is probably doing some sort of signal buffering maybe between the input triggers and the high-speed logic board. But this whole board, the way it is mounted in here between these edge connectors, I just found really intricate and interesting engineering. And that's popular throughout this whole camera. This power board is also interfaced. It's hard to see here without disconnecting everything. But it also interfaces via like a card edge connector. You can kind of see it right there in the center of the frame. And if we go and look at the other side of this board, So this is the other side of that power board, which it looks like most of the power is again coming through an edge connector here. Interesting, instead of cables. They do have some cables here. My assumption is this is power for the thermal electric cooler, considering it goes near the aluminum block on the other side. You have a fan mount. They have some high density interconnects like here. They also have those similar interconnects on the high-speed board. So my assumption is programming, firmware update, debugging, etc. They probably use that. In general, a pretty compact and interesting design for this camera. I really like what they did. They put a lot of thought into it. They work pretty well. All right, I'm not going to try and reassemble it on camera here, but hopefully you can kind of see the overall rundown. If you wanted to disassemble this camera yourself to check anything out, you can do it relatively safely without damaging it. There is no warranty sticker, etc. Who knows, after this video, maybe Photometrics is gonna go that route. But it's a pretty decent electrical and mechanical design, I would say. The one shortcoming that I've found using these is if you need any precision alignment, one, from camera to camera, it seems like the alignment of the image sensor with respect to these mounting faces is not good. And these mounting faces are also not precision machined. They're just cast aluminum. So if you have multiple cameras that you're swapping in and out of a fixture, etc., it's not the most ideal platform. But as far as low light sensitivity and simplicity speaking, this Prime 95 system is a pretty solid deal. All right, hopefully you guys learned something from this high-level teardown video. In general, these cameras are pretty nice. My only two feedbacks are the mounting plates are not really precisionally machined. That's actually made worse by these plastic extruded corners. Sometimes they're a little higher than the plate, which means depending on how much you compress those corners as you screw it in, it affects kind of that alignment and can add to tilt. The other major caveat I have with this company is they advertise a global shutter. What that means is you simultaneously are exposing all of the pixels at the same exact moment, and then you stop exposing your reading out. So you snap the entire image at a set moment in time. That's not really how this camera works. What it does is it will send out a trigger signal when it is exposing all of the pixels, so you can have a flash that then lights up and helps you take that picture when all of the pixels are being exposed. The problem is some amount of the frame is being exposed before that happens, some amount of the frame is being exposed after. So if you're not using an external flash to take the images, it's really not a global shutter at all. You have a time varying exposure and readout across the frame. For a lot of use cases, probably not a huge deal, but if you're trying to do like high speed imagery of light that's changing, you'll see basically like shutter tear or time variation across the frame, which in my application is a small challenge to deal with on occasion. All right, that's it, guys. Thank you for watching this video. Hopefully you found it interesting.